Good morning, everyone. I am Sonal Thorve from IISER Pune. I welcome you all to the 64th Sunday session. Before we go to the Sunday session, let us get introduced to IISER Pune. IISER stands for Indian Institute of Science Education and Research. You can see a picture of IISER Pune campus over here, taken in the evening time. यहाँ पे आपको आइसर पुणे का बहुत सुंदर सा कैंपस दिखाई देगा. आइसर पुणे का मोटो जो है वो है वेयर टुमारो साइंस बिगिंस टुडे. दिस इज श्रीमती इंद्रानी बालन साइंस एक्टिविटी सेंटर, जहाँ पे बैठ के आज हम आपके साथ बात कर रहे हैं, आपसे जुड़ रहे हैं. सो श्रीमती इंद्रानी बालन साइंस एक्टिविटी सेंटर, एज द नेम सजेस्ट, इट्स अ साइंस सेंटर. इसके अंदर बहुत सारी एक्टिविटीज होती है. आइए देखते हैं इसकी पिक्चर. दिस इज द लैब ऑफ साइंस एक्टिविटी सेंटर. यहाँ पे आपको दिखाई देगा कई सारे साइंस टॉयज दिख रहे हैं, कई सारा सामान दिख रहा है. सो यूजिंग दिस मटेरियल वी डेवलप साइंस टॉयज, वी डेवलप साइंस एक्सपेरिमेंट्स, एंड वी यूज these experiments to show to students, school students as well as school teachers. You can see a picture of a school visiting IISER Pune. IISER Pune conducts regular workshops as well as campus visits. यहाँ पे आके स्कूल के बच्चों को IISER पुणे के बारे में जानकारी मिलती है. 12th के बाद आप IISER में कैसे एडमिशन्स ले सकते हो, यहाँ पे कौन से प्रकार के स्टडीज़ होते हैं, किस तरह से होते हैं, यहाँ का इंफ्रास्ट्रक्चर क्या है, ये जानने को मिलता है. और उसके साथ साथ आप अपने जैसे इस अगले पिक्चर में देख पा रहे हो, बच्चे एक आनंद लेके यहाँ से जाते हैं, एक खुशी लेके जाते हैं. ये खुशी जो है ये उस बात की है जो विषय हमें कठिन लगते थे वो इतने कठिन नहीं है. साइंस एंड मैथ्स आर नॉट दैट डिफिकल्ट एज वी हैव ऑलवेज थॉट अबाउट, बट वी कैन ऑल्सो हैव फन वाइल लर्निंग दोज सब्जेक्ट्स. ये खुशी बाकी बच्चों तक भी पहुंचाने के लिए हमारे यहाँ पे टीचर्स वर्कशॉप्स भी होते हैं, टीचर्स ट्रेनिंग्स होते हैं, वेयर वी शेयर द कंटेंट एंड हाउ टू share these things, how to make our science and maths classrooms interactive to the teachers. So this is about IISER Pune and Science Activity Center. Let us start with our Sunday session now. The topic of today's session is us and our star. इसमें हम जानने वाले हैं कुछ पास्ट और कुछ फ्यूचर इवेंट्स के बारे में. एक बहुत ही लेटेस्ट 3 दिन पहले हाइब्रिड सोलर इक्लिप्स इवेंट हुआ था. ये नाम कुछ नया नया लग रहा है, हाइब्रिड. इसके बारे में हम जानेंगे, इसे हाइब्रिड क्यों कहा जाता है. उसके बाद हम जानेंगे अपकमिंग इवेंट जीरो शैडो डे के बारे में. इंटरनेशनल डे ऑफ लाइट क्या होता है इसके बारे में भी हम जानेंगे. और उसके बाद सन के एक्टिव मोड के बारे में जानेंगे. व्हाट इज द सन विथ इट्स एक्टिव मोड ऑन. शुरुआत करते हैं हाइब्रिड सोलर इक्लिप्स से. अगर आपने न्यूज में पढ़ा होगा, कहीं लाइव देखा होगा, तो 20 अप्रैल 2023 में न्यूजीलैंड और ऑस्ट्रेलिया के कुछ पार्ट्स में हमें सोलर इक्लिप्स दिखाई दिया था. अगर आपने वो ऑब्जर्व किया होगा तो that was a total solar eclipse observed from these places, these islands, some of the islands. Or hybrid is a term which is used for a rare type of a solar eclipse. ये solar eclipse ही है, लेकिन कुछ जगह पे annular और कुछ जगह पे total दिखता है. और ऐसा कैसे होता है, तो we are going to learn about that. हम सब ज्योग्राफी के बुक्स में ये पढ़ते हैं कि इक्लिप्सेस जो होते हैं वो शैडोज की वजह से होते हैं. एंड वी ऑल्सो नो, वी हैव ऑब्जर्व दैट शैडोज आर फॉर्म्ड व्हेन एनी ऑब्स्टेकल कम्स इन बिटवीन द सोर्स ऑफ लाइट एंड द ऑब्जर्वर. जैसे सूरज और धरती के बीच में चांद आता है, चांद की शैडो तैयार होती है. एंड द इक्लिप्सेस आर ऑब्जर्व ओनली व्हेन the shadow is formed on the earth. शैडोज के 3 टाइप्स होते हैं, अम्ब्रा, पेनम्ब्रा एंड एंटम्ब्रा। अम्ब्रा जो है दैट इज द डार्केस्ट रीजन ऑफ द शैडो, पेनम्ब्रा इज द लाइटर पार्ट विच इज सराउंडिंग द शैडो एंड एंटम्ब्रा इज अपोजिट टू द अम्ब्रा। जब सूरज और धरती के बीच में चांद आता है तब चांद की जो शैडो है वो स्पेस में फॉर्म होती है, एंड ओनली ऑन दोज न्यू मून डेज व्हेन द अर्थ पासेस थ्रू दैट शैडो हमें सोलर इक्लिप्स दिखाई देते हैं। यहाँ पे आप देख रहे हो लाइट सोर्स जो सूरज है, यहाँ पे चांद है, अगर तो अर्थ अगर इनमें से गुजरेगी तो देयर विल बी 3 टाइप्स ऑफ सोलर इक्लिप्सेस। इफ penumbra is falling on the region where you are in, you will see partial solar eclipse. अगर आप पेनम्ब्रल रीजन में हो आपको पार्शियल सोलर इक्लिप्स दिखाई देगा, जैसे अक्टूबर 2022 में हमें दिखाई दिया था। अगर आपके रीजन से अम्ब्रा गुजर रही हो तो आपको दिखाई देगा टोटल सोलर इक्लिप्स, जैसे परसों के दिन ऑस्ट्रेलिया से दिखाई दिया। और अगर आप एंटम्ब्रल रीजन में हो तब आपको दिखाई देगा एन्युलर सोलर इक्लिप्स या फिर कंकणाकृति सूर्य ग्रहण, जिसमें सूरज की बाहरी जो एज है वो हमें दिखाई देती है। अब मैं अपने चेहरे की तरफ पॉइंट कर रही हूँ क्योंकि मैं इसका इस्तेमाल एक डेमोन्स्ट्रेशन के लिए करने जा रही हूँ। तो मेरे पास अभी ये अर्थ का गोला है जिसे हम चांद समझने वाले हैं। So if I am the sun, you are the observer, the earth. Observe what is going to happen. When the moon is passing between the earth and the sun, अगर ये चांद की जो शैडो है वो अर्थ पे आती है, if it's a umbra, you are going to see a total solar eclipse. If it's a penumbra, it is going to be partial solar eclipse. And if it's an antumbra, you're going to see the edge of the sun, edge of the sun's disk. This is going to be the annular solar eclipse. अब annular solar eclipse और total solar eclipse में फर्क क्या है? अर्थ जो है, अर्थ इज राउंड, राइट? अर्थ इज राउंड and we can see that in this solar eclipse, the hybrid one which we just saw, इसमें कुछ इंटरेस्टिंग हुआ था। इसमें टोटल और एन्युलर सोलर इक्लिप्स एक ही दिन दिखाई दिए थे। वो क्यों हुए? तो इट इज बिकॉज दैट द अर्थ इज कर्व्ड। यहाँ पे आप देख रहे हो अर्थ कर्व है, और जब मून अपनी कक्षा में से पास हो रहा है, देर आर सम रीजन जहाँ पे अम्ब्रा पहुंची ही नहीं। अर्थ गोल होने की वजह से अम्ब्रा यहाँ तक आके पहुंची, लेकिन उसके आगे एंट अम्ब्रा हुई थी, और फ्रॉम देयर यू कुड सी एन्युलर सोलर इक्लिप्स। यहाँ पे आप देख सकते हो इस पिक्चर में, हम वापस पीछे जाते हैं, यहाँ आप देख सकते हो कि अर्थ अगर अम्ब्रा में होती है तो इट इज क्लोजर टू द मून। अर्थ अगर पेन अम्ब्रा में होती है कोई भी रीजन तो इट इज फार्दर फ्रॉम द मून देन द रीजन इन द अम्ब्रा। और ये कब पॉसिबल है कि एक ही दिन में हमें दोनों टाइप दिखे? ये उस वक्त पॉसिबल है जब अर्थ राउंड है, अर्थ का कर्व है, और इक्लिप्स के वक्त यहाँ भी शैडो फॉल हो रही है, यहाँ भी हो रही है, यहाँ भी हो रही है, राइट? सो जो क्लोजर वाला रीजन है वहां से हमें टोटल सोलर इक्लिप्स दिखाई देगा, जैसे ऑस्ट्रेलिया न्यूजीलैंड से दिखाई दिया। और ये जो रीजन्स है जो दूर है वहां पे हम एंटम्ब्रा देख रहे थे, और एंटम्ब्रा की वजह से मून जो है वहां से थोड़ी दूरी पे था। अगर आप ऑब्जर्व करो, कोई भी चीज हमारे नजदीक जब होती है तो बड़ी दिखती है, दूर जाती है तो छोटी दिखने लगती है, हालांकि चीज का साइज जो है वो उतना ही रहेगा। तो जैसे चांद जो है वो उतना ही है, लेकिन थोड़ा सा दूर होने की वजह से सूरज की बाहरी जो एज है वो हमें दिखती है, और वहां से एन्युलर सोलर इक्लिप्स हमें दिखता है। सो दैट इज व्हाट हैपेंड ऑन 20 अप्रैल 2023। तो यहाँ पे अगर आप देखें तो हमें एंट अम्ब्रल रीजन से दिखाई दिया एन्युलर सोलर इक्लिप्स और अम्ब्रल रीजन से दिखाई दिया टोटल सोलर इक्लिप्स। ऑफकोर्स पेनम्ब्रल रीजन में जहाँ से भी पेनम्ब्रा पास हुई वहाँ पे हमें पार्शियल सोलर इक्लिप्स दिखाई दिया। That is the reason why we called this eclipse as hybrid solar eclipse. You can see some snapshots of the maps over here. इन मैप्स में अगर आप देखो तो यहाँ पे आप देख सकते हो इस जगह पे हमें एन्युलर दिखाई दिया था, यहाँ पे हमें टोटल सोलर इक्लिप्स दिखाई दिया और यहाँ पे अगेन एन्युलर सोलर इक्लिप्स. So this is about the hybrid solar eclipse that happened on 20th April. ऐसे इंटरैक्टिव मैप अगर आपको देखने हो तो यू कैन रिफर दिस timeanddate.com, जहाँ पे आपको आगे के कई सालों के सोलर इक्लिप्सेस और लूनर इक्लिप्सेस की जानकारी भी मिलेगी. एंड यू कैन ऑल्सो चेक if you can see the eclipses from where you are. You can plan your observations or your tours accordingly if you want to chase the eclipses. So this was about hybrid solar eclipse. इसके बाद हम देखते हैं what is zero shadow day. Zero shadow days are actually happening to different places right now or very in a near future. मतलब अगले महीने में मई के 13 तारीख को पुणे में भी जीरो शेडो डे होने वाला है. तो ये जीरो शेडो डे क्या है? हम लाइट और शेडोज की ही बात कर रहे हैं. अभी सन की वजह से, मून बीच में आने की वजह से, मून की शेडो से हमें सोलर इक्लिप्स दिखता है, ये हमने देखा. अब मून के शेडो तो नहीं है, लेकिन रोज हमें जो शेडोज दिखती है वो हमारे आसपास की वस्तुओं की है, हमारी है, right? So we can observe the shadows of objects around us. तो हमें रोज हमारे आसपास ये लाइट एंड शेडोज का प्ले दिखाई देता है. अगर आप गौर से देखो तो जैसे जैसे सूरज पूरब में उगकर पश्चिम की तरफ जाता है और सेट होता है, वैसे हमारी शेडोज की लेंथ भी कम ज्यादा होती रहती है. When sun is near horizons, तब हमारी शेडोज की लेंथ जो है वो सबसे ज्यादा होती है और अपोजिट डायरेक्शन में होती है. जैसे इफ द सन इज राइजिंग इन द ईस्ट, सन हैज एरोज इन द ईस्ट, you will see your shadow at the longest towards west. As the sun starts coming up in the sky, rising up in the sky, the length of the shadow gets shorter and shorter. And near noon time, you can see that the shadow has become minimum. But many times you will observe that this shadow is either in the north or south. It is not exactly beneath your feet as it is supposed to be when sun is overhead. इसका मतलब है सूरज हर रोज हमारे सर के ऊपर नहीं होता, ओवरहेड नहीं होता. अब यहाँ पे आप देख सकते हो कि कुछ चीजें यहाँ पे रखी गई है. यहाँ पे कुछ सिलेंडर्स है, कुछ कोन्स है, कुछ ग्लोब्स है, कुछ मज़ेदार बॉल्स है, कुछ सिलेंडर्स है. तो यहाँ स्कूल के बच्चे आके ऑब्जर्व कर रहे हैं कि इनकी शेडोज कैसे फॉर्म हो रही है, कैसे मूव हो रही है, जैसे सूरज आसमान में भ्रमण कर रहा है या आसमान में हमें सूरज की अपैरेंट मूवमेंट दिखाई दे रही है, और कैसे ये शेडोज बदल रहे हैं, जीरो या फिर मिनिमम हो रहे हैं. यहाँ आप देख सकते हो, यहाँ दो छोटे बच्चों का फोटो है. उनकी शेडोज अगर आप देखो तो बहुत ही मिनिमम शेडो आपको दिखाई देगी ऑन द जीरो शेडो डे. वी आर नॉट परफेक्ट सॉलिड सिलेंडर्स. इसकी वजह से हमारी शेडो जो है वो एग्जैक्टली हमारे बेस पे सर्कुलर नहीं आती, लेकिन हमारी थोड़ी सी शेडो हमें दिखती है क्योंकि हम परफेक्टली सॉलिड सिलेंडर तो नहीं है. तो हमारी शेडो जो है वो इस तरह से हमें दिखाई देती है. तो हमारे लिए ये मिनिमम शेडो डे होता है. अब ये क्यों होता है और ये कहाँ होता है? क्या जीरो शेडो डे सब देख सकते हैं, सब जगहों से हमें दिखाई देता है? तो इसका जवाब है नहीं. जीरो शेडो डे सिर्फ उन्हीं लोगों को दिखाई देता है जो लोग ट्रॉपिक ऑफ कैंसर और ट्रॉपिक ऑफ कैप्रिकॉर्न के बीच में रहते हैं. ट्रॉपिक ऑफ कैंसर के अबव नॉर्थ की तरफ और ट्रॉपिक ऑफ कैप्रिकॉर्न के नीचे साउथ की तरफ जीरो शैडो डे कभी भी नहीं हो सकता। अब इसका रीजन क्या होगा? हमने अभी अभी देखा कि कैसे सूरज ईस्ट से लेके वेस्ट तक जाता है तो हमारी शैडोज की लेंथ कम और ज़्यादा होती है, बढ़ती और घटती जाती है और वापस बढ़ती है, राइट। ये तो होता है दिन और रात जो हम बोलते हैं, सूरज का उगना और फिर सेट होना, वो होता है अर्थ की रोटेशन की वजह से, खुद के अराउंड घूमने की वजह से। लेकिन जीरो शैडो डे साल में ये दो ट्रॉपिक्स के बीच में जितनी जगह आती है वहां पे सिर्फ 2 बार होता है, रोज नहीं होता। इसका मतलब इसके लिए कुछ और मोशन जिम्मेदार है और वो मोशन है अर्थ का रिवॉल्यूशन अराउंड द सन। सो अर्थ्स रिवॉल्यूशन इज रिस्पॉन्सिबल फॉर दिस इवेंट, फॉर दिस फिनोमेना। Earth's axis, as we all study, is tilted, right? Tilted with respect to the plane of its orbit. अब ये tilted होने की वजह से क्या होता है, अर्थ का इक्वेटर is tilted with respect to the plane of its orbit by 23.5 degrees. And that's the reason sunlight दोनों साइड या फिर दोनों हाफ्स में इक्वली नहीं पहुंचता। दैट इज वाई व्हेन देर आर लॉन्गर डेज इन वन हेमिस्फीयर, देर आर लॉन्गर नाइट्स इन द अदर एंड वाइस वर्सा। सो राइट नाउ वाइल इंडिया इज फेसिंग समर, इंडिया में समर हो रहा है अभी, राइट, इंडिया में समर हो रहा है, लेकिन ऑस्ट्रेलिया में इट्स अ विंटर सीजन। 6 महीनों बाद इट इज गोइंग टू बी अपोजिट। इंडिया में जब विंटर होगा तब ऑस्ट्रेलिया में समर सीजन शुरू होगा। अब ये जो रिवॉल्यूशन है, हमें पता है अर्थ टेक्स 12 मंथ्स और 365 डेज टू रिवॉल्व अराउंड द सन। इस रिवॉल्यूशन के दौरान सिंस अर्थ एक्सिस इज टिल्टेड, टिल्ट होने की वजह से क्या हो रहा है कि सन का जो आसमान में स्थान है, पोजीशन है, वो हमें बदलता नजर आता है नॉर्थवर्ड एंड साउथवर्ड। इसे हम दक्षिणायन और उत्तरायण भी बोलते हैं। तो सन का, सूरज का जो भासमान भ्रमण है वो इस तरह से भी हमें दिखता है। अगर आप 21 जून, जिसे हम साल का सबसे बड़ा दिन बोलते हैं, उस वक्त दोपहर को अपनी शैडो दें तो आपकी शैडो कौन सी डायरेक्शन में दिखाई देगी, वो आप अगर देखोगे तो इट विल बी इन द डायरेक्शन ऑफ साउथ। इसका मतलब सूरज हमारे सर से नॉर्थ की तरफ है। और वही शैडो अगर आप 21 दिसंबर को देखोगे, मतलब विंटर सोल्स्टिस के वक्त देखोगे, विच इज द लॉन्गेस्ट नाइट फॉर अस, उस वक्त अगर आप नून में अपनी शैडो देखोगे तो वो आपको दिखाई देगी उत्तर की तरफ या फिर नॉर्थ की तरफ। इसका मतलब है सन विल बी टुवर्ड्स साउथ फॉर अस। सो सन का ये जो अपेरेंट मोशन है नॉर्थवर्ड एंड साउथवर्ड, उसकी वजह से ट्रॉपिक ऑफ कैंसर और कैप्रिकॉर्न के बीच में जितनी भी जगह आती है, सन कम्स ओवरहेड ओनली ट्वाइस ऑन दीज प्लेसेस। यहाँ पे अगर आपको दिखाई दे रहा है, सो ट्रॉपिक ऑफ कैंसर 23.5 डिग्रीज नॉर्थ, ट्रॉपिक ऑफ कैप्रिकॉर्न 23.5 डिग्रीज साउथ। 21 दिसंबर, जिसे हम विंटर सोल्स्टिस बोलते हैं, हमारे यहाँ पे इट्स अ लॉन्गेस्ट नाइट। यहाँ से सूरज जैसे जैसे ऊपर आता जाता है, आप देख सकते हो 21 जून तक, और 21 जून को आके यहाँ पे उसका नॉर्थवर्ड मोशन जो है वो थम जाता है, रुक जाता है। इसीलिए हम उसे बोलते हैं समर सोल्स्टिस। यहाँ पे रुक जाता है नॉर्थवर्ड मोशन और यहाँ से वापस वो नीचे आने लगता है, उसे हम दक्षिणायन बोलते हैं। और वो नीचे मतलब साउथ की तरफ 21 दिसंबर तक भ्रमण करता है और उसके बाद वापस वो ऊपर जाता है। दिस कंटिन्यूज। और उसके दौरान आप जहाँ पे हो, ट्रॉपिक ऑफ कैंसर और कैप्रिकॉर्न के बीच में, वहाँ पे आपके सर के ऊपर से वो 2 बार गुजरता है, एक नॉर्थवर्ड जाते वक्त और एक साउथवर्ड पीछे आते वक्त। और इसीलिए इन दो ट्रॉपिक्स के बीच में जितनी जगह है वहाँ पे 2 बार जीरो शैडो डे होता है। अगर आप दिल्ली में रहते हो या फिर आपका लैटिट्यूड जो है 23.5 डिग्री नॉर्थ से ऊपर या 23.5 डिग्री साउथ से नीचे होगा तो आपको कभी भी जीरो शैडो डे एक्सपीरियंस करने को नहीं मिलेगा एट योर प्लेसेस। You have to move to other place to observe this event. So you can also see, if you want to check that when is going to be the zero shadow day at your place, अगर आप इन ट्रॉपिक्स के बीच में रहते हो तो you can use this Android application which is free to download and very interactive, जहाँ पे you can actually see the simulations, जिसमें आप देख सकते हो कि कैसे सन की मूवमेंट अर्थ के अराउंड हो रही है और कैसे शैडोज फॉर्म हो रहे हैं। और वहाँ पे आपको डेट्स भी दिखाई देंगे, टाइम भी दिखाई देगा कि कब आपके यहाँ पे जीरो शैडो डे दिखाई देगा। आइए जानते हैं इंटरनेशनल डे ऑफ लाइट के बारे में। अभी हमने लाइट एंड शैडोज के बारे में बहुत कुछ सुना। ग्रहण होते हैं, जीरो शैडो डेज होते हैं, शैडोज हमें रोज दिखाई देते हैं आसपास। लाइट की वजह से बहुत चीज़ें होती है। लाइट इज़ वेरी इंपॉर्टेंट फॉर लाइफ। और जब आर्टिफिशियल लाइट सोर्सेस बने नहीं थे, इन्वेंट ही नहीं हुए थे, दैट टाइम सन वॉज द ओनली सोर्स ऑफ लाइट एंड हीट फॉर अस। उसके बाद धीरे धीरे जैसे टेक्नोलॉजी बढ़ती गई, एडवांस होती गई, वैसे हम कई सारे लाइट सोर्सेस और टेक्नोलॉजी इस्तेमाल कर रहे हैं अब फॉर सस्टेनेबल डेवलपमेंट। So to appreciate the presence of light and the role it plays in our life, we celebrate International Day of Light on 16th May every year worldwide. Now let us come to a picture which is again from the eclipse which happened on 20th April. ये पिक्चर में अगर आप देखोगे तो इट्स अ पार्शियल सोलर इक्लिप्स। ये पार्शियल सोलर इक्लिप्स का पिक्चर है। इसमें अगर आप गौर से देखो तो यू कैन सी सम फीचर्स जिनके अराउंड यहाँ सर्कल किए हैं, यहाँ पे भी आपको दिखाई देगा। कुछ अलग फीचर्स हमें यहाँ पे दिखाई दे रहे हैं एंड दीज फीचर्स आर वेरी इंटरेस्टिंग। ये फीचर्स, इफ यू सी दीज रेड सर्कल्स, द फीचर्स इनसाइड द रेड सर्कल्स, ये जो है ये कुछ डार्कर स्पॉट्स हैं जो सूरज के डिस्क पे हमें दिखते हैं, सोलर डिस्क पे। यहाँ जो येलो सर्कल्स में आपको दिख रहा है, यहाँ पे कुछ फाउंटेन की तरह उछलता हुआ आपको दिख रहा है। सो दीज आर सम डिफरेंट फीचर्स ऑन द सन। सो दीज टू फीचर्स आर टोटली डिफरेंट। देयर आर मेनी डिफरेंट इवेंट्स अकरिंग ऑन द सन। तो हमने अब तक सिर्फ सन की वजह से हम क्या क्या एक्सपीरियंस करते हैं, क्या क्या देख सकते हैं, ये देखा। लेकिन इसके आगे वी आर गोइंग टू लर्न अबाउट व्हाट हैपन्स ऑन द सन, व्हाट इज सन व्हेन इट्स ऑन इट्स एक्टिव मोड, उस पर क्या क्या होता है, ये हम जानने वाले हैं। और वो जानने के लिए हमारे साथ आज जुड़ने वाली है डॉक्टर हेलन मेसन। So let me introduce Dr. Helen Mason in brief. Dr. Helen Mason is a well-known solar astrophysicist. She is from University of Cambridge. She has worked with NASA for Solar Heliospheric Observatory, which we all know as SOHO, as well as many different space solar missions with NASA, ESA, and she has also worked with India's ISRO. She is currently working on ISRO's upcoming mission Aditya L1, and this is very exciting. So let us all learn about our star, the Sun, and the space solar missions from Dr. Helen. So I welcome Dr. Helen Mason on stage. Over to you.
So I'm very pleased today to share with you some of the things that I know about the Sun, our star. So I've studied the Sun for many, many years with many space missions, and I also collaborate closely with colleagues in India. So I'm over here in India at the moment working with my colleagues, and Aditya L1, an Indian space mission to study the sun, will be launched this year. So it's very exciting for us at the moment. In this picture here, you can see a picture of the sun taken from space, and on the side of the sun you can see a huge explosion. So the sun isn't always quiet. Sometimes the sun is quiet, but sometimes there are explosions. But the sun is just an ordinary star, just like many other stars that we see in the sky. It gives us light, it gives us warmth, it gives us energy, it gives us everything we need for life here on Earth. But it's an ordinary star, like many other stars in the sky. So if we can understand how the sun works, then we can understand the other stars as well, and other astrophysical bodies. So, where is the sun in the solar system? This is a picture of a galaxy which is similar to our galaxy, similar to the Milky Way galaxy, and the solar system exists on one of those spiral arms. So our sun is just one of 100 billion stars. That's a huge number of stars in our galaxy, the Milky Way. And we live in a very quiet little neighborhood. But it's just a normal star. There are stars that are younger than the sun and the stars that are older than the sun when we look in the night sky. So how old is the sun? Well, the sun is 4.5 billion years old. That's a very large number. So that's 4,500 million years. And this is a stars being formed, other stars being born. It's an image taken from space, from the Hubble Space Telescope. It's a very famous image called the Pillars of Creation. It's actually the Eagle Nebulae. In very cold clouds of gas, the stars are being formed inside of them. The universe itself is much older. It's 13.5 billion years old. And how long will our sun live? Well, our sun is about halfway through its lifetime. It's going to live for another 6 billion years. It's a very long time. And when it comes to the end of its lifetime, it'll grow larger into a red giant. And then eventually the outer atmosphere will puff off, and in the core we'll be left with a white dwarf. So it'll end up as a planetary nebulae. If it were more massive, if it were about 10 times as massive, then its core would end in a spectacular way as a supernova. And then in the core we'd be left with a neutron star or a black hole. This is an image of the Butterfly Nebulae, which is a planetary nebula, and it's also taken with the Hubble Space Telescope. So how big is our sun compared to the Earth? Well, the sun is huge compared to the Earth. So you can see the Earth there, and that little dot there represents the size of the Earth. And Jupiter is about 10 times the size of the Earth. Well, you could fit over 100 Earths across the middle of the sun and around 1 million Earths inside the sun. So the sun is absolutely huge compared to the size of the Earth. So what else do we know about our sun? Well, we said it's a middle-aged star halfway through its lifetime. It's our energy source. It gives us all the energy we need. We've said it's extremely big. Now in this picture here, you can see a lot of dark patches on the sun. These are called sunspots, and they're areas where the magnetic field on the sun is very strong. If you see that little dot towards the middle of the sun, that's about the size of our Earth. It's a long way away, and light travels extremely fast, but even at the speed of light, it takes over 8 minutes to light to get from the sun to the Earth. It's massive, 2 times 10 to the 30 kilograms, that's 30 zeros there. And the temperature on the surface of the sun is just under 6,000 degrees. So how is the energy formed in the sun? Well, the energy is formed in the very core of the sun with a process called nuclear fusion, where hydrogen turns into helium. And when hydrogen turns into helium, a little bit of mass is lost, producing a huge amount of energy. This is the process that is going on in all the stars, producing energy. And the core of the sun is 15 million degrees, very, very hot. That energy is carried out through different zones. It's carried out through a radiation zone, and then it's carried out by convection just beneath the surface. And here we can see convection on the surface of the sun. You can see little convection patterns on the surface of the sun. This image is taken from a telescope called DKIST, which is in Hawaii, and you can see the telescope in Hawaii there. So the gas bubbles up like porridge on a stove. The gas can bubble up and you can see it convecting on the surface of the sun. There you can see a little movie of it. You can see it moving around. So as I said before, sometimes the sun has spots on it, these dark patches. These are spots where the magnetic field is very strong, and because the magnetic field is very strong, the energy isn't able to come from beneath the surface in the same way as the surrounding surface. So those areas are a little bit cooler than the rest of the sun, which is why they look darker. So sometimes there's a lot of spots, and sometimes there's very few spots. And these spots represent how magnetically active the sun is. And when there's a lot of spots, then sometimes we get huge explosions on the sun, which shoot out material into space. And we got some beautiful phenomena here on Earth when those explosions hit the Earth. Those are called the aurora, the northern lights, the southern lights, aurora borealis and aurora australis. They are very beautiful. I've never seen them, but I hope that one day I shall see them. So this is somebody you're probably very familiar with, Galileo, who lived in Italy. And Galileo was one of the first astronomers to use a telescope to look at the night sky. Telescopes existed, but they used to look at ships in the distance. He thought, well, what would happen if I pointed a telescope at the night sky? Now, I should say you should never look at the sun. Never look at the sun. It's too bright. You can either project an image of the sun or use a very special solar telescope to look at the sun. He projected an image of the sun and he drew what he saw. And he saw these sunspots on the sun. These are his actual drawings. And you can see he drew it at the same time each day, and you can see that the sun is spinning. So the sun takes about 25 days to spin at its equator. Now, since it's a gas, it doesn't have to spin at the same rate everywhere, and it spins a little bit more slowly at the poles. It takes about 33 days to spin at the poles. Now, some of these sunspots, these regions where the magnetic field is very strong, can be very large, and here you can see a comparison with the size of the Earth. You could actually fit an Earth inside some of those sunspots. There's a few sunspots on the sun at the moment, because at the moment the sun is getting quite active again. There are several observatories in India, and here's just some examples. One I've been to in Udaipur in Rajasthan is built on a lake, very beautiful, and it has a telescope called Multi-Application Solar Telescope, which is being used to study the sun and to study those sunspots. Another in Kodaikanal is a very old observatory, solar observatory, and that also has a telescope, but there are other observatories on the ground in India. So what happens when the moon goes between the Earth and the sun? There are occasions, probably about once a year somewhere, but not everywhere, that we get what's called a total eclipse of the sun. The disk of the moon exactly blocks out the disk of the sun. Now, the disk of the sun is about 1 million times brighter than that ring of light you can see, which is the solar atmosphere. So we can only see that solar atmosphere in the visible when we block out the disk of the sun. So the moon exactly blocks that out. This disk of light is called a crown of light. It's called a corona. That's the name for it. That's the part of the atmosphere. And can you see all those strange structures there? Those are where the gas has traced out the magnetic field on the sun, because the gas is charged. It's very, very hot. That corona is 1 million degrees. So the surface of the sun is around about 6,000 degrees, but that corona, that atmosphere of the sun, is 1 million degrees. And that's one of the things that scientists have been trying to understand. And we've made quite a lot of progress, but there are still a few mysteries we need to solve about that. Because that corona is very, very hot, 1 million degrees, it emits very strongly in X-rays and ultraviolet light. And here's a picture taken with an X-ray camera sensitive to X-rays, from a satellite called Yoko, which is a joint Japanese NASA satellite. And you can see how different the sun looks like. All of those bright regions are very hot, and you can see some dark regions. Those are regions where the magnetic field is open and the corona has flowed out into space, called the solar wind. So the gas flows from the sun all the time, and occasionally there are bursts of gas as well that flow from the sun. The regions that are very bright, that's where the sunspots are underneath. And the cycle of activity is round about 11 years. So the sun goes from being very quiet to being very active to being very quiet again. Now, this is a satellite that I've worked on for many, many years. It's launched in 1996. This is called SOHO, the Solar and Heliospheric Observatory. And it was a satellite with many different instruments to study the sun, the inside of the sun, the atmosphere of the sun, and that solar wind that flows off the sun. And it was at a very special location, it still is, it's still being used, called the Lagrange point, which is the point where the pull of the sun by gravity balances the pull of the Earth. It's quite close to the Earth. It's about 1/100th of the way between the Earth and the sun, and it goes around the sun with the Earth. Now that's interesting because actually Aditya L1 is going to be out at the Lagrange point too. That's also going to go around the sun with the Earth, and we'll be able to see the sun 24 hours a day from Aditya L1. Now here's a huge explosion on the sun. Remember, I told you how small the Earth is in comparison. That explosion is huge in comparison to the size of the sun. And here you can see something lifting off from the sun and going way out into space. Now that's going off to the side of the sun, but if that explosion and all that material were coming towards the Earth, then it would affect the Earth's environment. But we're really lucky here on Earth because we have our own protection layer, and here's a drawing of it. It's just an illustration. We're protected by our own magnetic field. So there's the sun on the left-hand side and the Earth on the right-hand side, and you can see illustration, which is the Earth being protected by its own magnetic field. So the ionized gas that comes off the sun scoots around the Earth, but occasionally, if it hits the Earth, or if there's some shock wave that comes, it will disturb the Earth's magnetic field, and the Earth's magnetic field will change its shape dramatically, and particles will shoot down to the polar regions, down what we call the magnetic field lines, and that's what causes the aurora, and can cause lots of other problems for astronauts in space, for example. It can give radiation damage, or it can knock out the electricity, or it can damage satellites, or it can induce currents as well. So there's lots of other effects. Because we depend so much on technology now, what the sun does can affect us quite dramatically and our technology, and we need to understand it better. So this is a picture of the beautiful aurora taken from the International Space Station. You can see a little bit of the International Space Station there on the right-hand side. So we need to understand what happens on the sun, what causes the explosions on the sun, and these ejections of material that shoot out from the sun in different directions. We need to understand whether they're coming towards us and whether they're going to be a problem for us and for our technology. So that's what scientists are studying, and that's also what Aditya will be studying. It will be studying the sun and the gas that flows out from the sun, sampling that, and trying to understand better how the sun works and also how it affects the Earth. There are two other satellites at the moment that are going very, very close to the sun. The one was launched in 2018 and one was launched in 2020. One's called Parker Solar Probe. Parker was a very eminent stellar and solar astronomer, and he had the satellite named after him. It's going very close to the sun to study the sun and that solar wind and the explosions that come from the sun. And the other is called Solar Orbiter, which is also orbiting close to the sun so that we can understand it better. So, ISRO's Aditya L1 will be India's first mission to the sun, and it will be launched in 2023. And indeed, the group here at IISER have been involved in building one of the instruments, and Professor Durgesh Tripathi at IISER is leading that group. So this is ISRO, the Indian Space Research Organization's satellite, and we're very excited about it because it's going to produce some amazing new results which will help us to better understand the sun. So I'm here to work with them just for a short time, and I also have been working with schools and children when I visit India, which is a great pleasure for me. Here you can see in a little bit more detail the instruments that will be on Aditya. There will actually be 7. There will be one to measure the magnetic field. There will be one to look at the ultraviolet light. There will be some that look at the X-ray light. And there will be some that will sample the solar wind that flows from the sun. I also run a project with schools in my own country, in the UK, and that brings artists and scientists together. And what we do is we do a science interaction, and then the artist shows the students some different art techniques, and we use those art techniques to illustrate what the students have learned about the science, and also to get them to do some writing about what they've learned, or to maybe do some poetry, or to do some other things. So here you can see there's a picture of Tim Peake, our astronaut from the UK that went into space on the International Space Station a few years ago. There's one of the huge solar explosions that I was talking about. Down in the bottom left-hand corner there's an installation made, an artwork made by one of the artists in our team, and this is made out of smart materials which glow in the dark, which is amazing artists. It's called the Sundress for the Yellow Giantess, made by Helen. And there you can see the aurora. So thank you very much for listening. I hope I've been able to tell you something about the sun that you didn't already know.
Thank you very much for a lovely talk, Helen. So we have some questions for you and we'd love to know their answers. So my first question will be, what inspired you to study astronomy?
As a child at school, I was always quite good at science and mathematics, and I enjoyed it, and I enjoyed sort of working things out. Wasn't very good at some of the other subjects like languages and history, but I enjoyed science and mathematics. And my father was an engineer, encouraged me very much and showed me how things worked and explained things to me. So I found it very interesting and exciting. And I remember as a very young child, just walking one night at night time in the dark and looking up at the stars and wondering, wow, I wonder what they're all about, and wanted to understand. So I was motivated as a child and then went on to study science. It was something that just interested me and I enjoyed it.
As you said that there are many interesting objects, many interesting astronomical objects in the universe. Then what is the reason behind choosing the sun? Why did you choose to study the sun?
I was interested in astronomy as a whole. But when I went to university, I had to do a research project as part of my coursework, and I did a project on the solar wind. And that got me a little bit interested in the sun. And then when I went on to do some more work after I'd got my first degree, I went to do some graduate work, and I was given a project which was about the total eclipse of the sun and analysing some data from a total eclipse of the sun. And then I was completely hooked. I loved the sun, so I was always very passionate about the sun.
We would like to know how has been your journey in this field.
I've had a fantastic life in science. I've worked with some amazing people. I've worked with people at NASA, people at European Space Agency, people in Cambridge, people in India, people all around the world. And we've worked on lots of different projects. And I've been really excited and enjoyed working with the people. I have to say that a space project is always a lot of teamwork, so I don't work on my own. I do a very specific part of the work, the science interaction, designing science observations, but there are lots of other people that I work with, engineers who build the instruments or people who operate the instruments. And for SOHO, for example, we worked at the Goddard Space Flight Center in the USA, NASA operated, and it was so exciting to actually be observing the sun, deciding what we wanted to learn about the sun, and then programming it each day, and then finding if the data we got back was what we wanted or what we expected. So working with a team, it was exciting always to see new observations coming and new things that we hadn't known before and that we learnt about.
So Helen, you have been in solar astrophysics for so many years, and you must have found answers to many questions. You must have solved the mysteries about many things about the sun. So what are the new things you are willing to explore in the future? Are there any such questions to which you would like to find the answers?
I have worked on lots of different aspects of the sun, but when you work in science, what you find is you address a science question, and quite often as you get the answer, you find more questions pop up. So as we kind of get answers to big questions, then we get lots of other questions happening. So I've worked on lots of different features of the sun. So for example, on the solar wind, I've looked for the source of the solar wind, where it's coming from on the sun, and I've published some papers on SOHO which explains partially where it comes from in that regard. I've looked at lots of small flares and some big flares and seen what causes them and how much energy they have and how much energy is released. And I've looked on the things that are like little jets of coming up from the sun, and this is with students and other people. And we now think that those feed into the solar wind, and we can trace the material from the surface of the sun into the solar wind. There are things we still don't understand. We don't understand what triggers a flare, when it's going to happen. We know it might happen sometime, but we don't know exactly when. We don't know exactly where different parts of the solar wind come from, and we're still trying to understand that, particularly the bursty bits that can cause us problems. So even though we've made a lot of progress and answered a lot of questions, it's like doing a big jigsaw puzzle. We've got quite a lot of the pieces, but some of the pieces are still missing there, and we're still looking for them, and we can achieve these with new instruments looking in a little bit more detail and new models that on computers that we build. And Aditya L1 will help us to complete the picture, or to at least make further advances in understanding the sun and its interaction with the Earth.
As you said, you are involved in Aditya L1 mission, which is India's own mission, solar space mission. Are you also involved in any other Indian space mission?
I've collaborated with my Indian colleagues for many, many years, and they've been over to work with me in Cambridge, and even had graduate students to come and study with me, and I've worked with them. But we've often worked on NASA projects or European Space Agency projects or other solar projects. But now we're in a situation where India has its own space projects, solar projects, and recently, for the past 3 or 4 years, I've been working on an instrument on Chandrayaan-2. It's an X-ray instrument called the X-ray monitor, which is looking at X-rays coming from the sun, the X-ray emission. It's a very sensitive instrument, best of its kind. We haven't had results like this before. It's based at IISER and the team at the Physical Research Laboratory in Ahmedabad. And we've worked online, we've Zoomed each week, and we've written lots of papers together understanding the X-ray emission that's coming from the sun in the context using other observations of the sun as well. So very excited to work with colleagues in India on that mission, and looking forward to working with colleagues on Aditya L1 when we begin to get some results from that too.
And the last question for you is, what message would you like to give to our students who are willing to be the scientists in future?
Being a scientist is very exciting, and if you're interested in science, don't let anybody put you off. Don't let them tell you it's not for you. You follow your dreams and the questions that you ask. Science is about life around us, whether it be astronomy, whether it be space, whether it be about the Earth's environment, which is also extremely important, whether it be about biology, biotechnology. Science offers us the opportunity to explore how things work and to improve the world around us in different ways. So if you're interested in science, then do follow it, and you need to work hard, but do follow that. If you're not interested in science, you're interested in other things, that's fine too. I think there's lots of people are very different, and it takes lots of different skills in this world to come together, to work together.
Thank you very much, Helen. Thank you very much for a lovely interaction.